So let's look at example 1, and we can use the table above as well to help us. Identify which functions are polynomials and justify your answers. For the polynomial functions, we're going to state the degree, so that'll be our highest exponent. The leading coefficient. The leading coefficient is going to be the number in front of that highest exponent. Okay, so the leading mean the first coefficient. Okay, and then the constant term. The constant term is going to be the term with no variable, which typically we have that at the end. Okay, so there will be no variable in a constant term. Okay, so let's look at the first graph. So equation. G of x equals the square root of x plus 5. This is a radical graph. We've already learned about radicals. This would be a radical graph shifted up 5. So it's actually not polynomial. So we don't have to answer all of those other questions about that. We'll just sort of say what type of function it is so that when you're going back and reviewing, you can remember this is a radical function. Okay, let's look at B. F of x equals 3x to the 4. If you've got an exponent here, even though it doesn't have a long trail of variables with exponents, it is still polynomial. So this is polynomial with degree 4 because that is the highest exponent. Okay, the leading coefficient, I'm just going to abbreviate so I don't have to write that out, is the number in front of the highest coefficient, so 3. The constant term, you might not think you see it, but technically it would have to be a 0 then, like a plus 0. So the constant term, again, I'm just going to abbreviate that, is 0. Let's look at C. G of x equals the absolute value x. If you have an absolute value, then it is not polynomial. So those are absolute functions. Or absolute values, sorry, absolute value functions. Let's look at D. So we've got a cubed, a squared, an x. This is polynomial. This is probably one of the more typical looking polynomial equations. So the highest exponent tells me the degree. So it's polynomial with degree 3. That also means it's cubic, all right? So you can kind of learn that language. It's cubic. This one here, I didn't mention it, but degree 4, if you look up top in your chart, it's quartic. All right, the leading coefficient then would be 2. And you always want to make sure this is in descending order. Sometimes they're in a different order, so you want descending order is highest exponent to no exponent. X cubed, x squared, x1, x to the 0. Constant term would be the term with no variable, so -1. Okay, let's look at E. This, if it's a fraction, is not polynomial. It is well, there's actually kind of 2 ways we could call this. So it's not a polynomial function. I guess I didn't really need to write the word function. Okay, this comes into the category of fractions, which we would call rational functions. If you were kind of trying to think ahead, thinking, what else could this be? This also could have been called a reciprocal function, and that's what we talk about in grade 11 course. And that's true. Reciprocal function is a type of a rational function. So we do a chapter on rational functions in this course. So that's why I put it that way. But both answers are true for this. Okay, the next one. So at first glance, I start to go, hey, it has an exponent. Maybe it's polynomial. It has to be a whole number. Okay, here's why. If it is, if it's a fraction, then really we can write this as a radical. X to the 1/2 is the same thing as square root of -7. So this is not polynomial. Okay, it's actually a radical function. So I'm just going to make a little note here that the exponents must be whole numbers. So exponents must be whole numbers. Okay, so if you see that, a lot of times we say, oh, they have exponents in them, but we got to be a little bit more specific when we're thinking of that.